This is so exciting. So we are going to learn how to prove using trig, and it's really very easy. You do need to be refreshed on the rules that we learned last time. We're going to use all of those today as we go about the trig proof. Okay. This is all algebra, so if you're good with algebra and manipulating, as long as you know your rules, you'll be just fine. So these are all the rules that we learned last time. We will use them today. So, and some of these, again, like these periodicity identities, we don't use these very often. Every once in a while you'll see them, but honestly, these ones don't come up that often. We use the quotient identities quite frequently, the reciprocal identities, and the Pythagorean identities, and the negative angles. So these ones will be the ones we will use the most often. Right? So what we're trying to do when we prove using trig is to say that one thing is another, is the same thing as something else. So what I'm trying to do here is I'm trying to say that this is the same thing as this. So in example 1, I'm going to show you how to manipulate this side to get this. In example 2, we'll manipulate the other side. In example 3, we'll manipulate both sides. You can't move anything from one side to the other side. Okay, this is not strictly algebra, this is proof. So what we're trying to do is to make this side and this side exactly the same. And we do that by using identities and simplifying. So I'm not going to touch this side. All I'm going to do is make this side look like that. So what am I doing? And I don't have to justify. I don't have to tell you what rules I'm using, but you need to show all of your work. This is super important. If you're not showing work, you will not get points for this, okay? Because I know that they're equal already. So here I did, this is difference of squares, which is the same thing as cosecant squared x minus 1. So that's what I did there. Now, to get here, there is a rule. You go back to your charts, okay? And I hope you have your charts with you, all right, that says that, this is one of the Pythagorean identities, that cosecant squared, now you have to manipulate it a little bit, cosecant squared minus 1 is the same thing as cotangent squared. So I can replace this with cotangent squared because of that rule. Notice I didn't have to justify or talk about it, but I showed my work. I did this and then that, okay? If I were to go straight from here to here, you would have no points because there has to be the step in between. I have to show this, all right? So that's example 1. Practice 1 in just a moment. Okay, so verify that this is the same as that. So what you're going to do is you're going to manipulate this side so it looks just like this. Go ahead and play with this just a little bit. See if you can use those rules that you have, and if you can make this side look like this side. All right, here's your I just lost my train of thought. Here's the solution. Okay, so what we did first is we rearranged the terms, okay? And I have 1 minus sine squared. Now, if you think back to the Pythagorean identity, I can replace 1 minus sine squared with cosine squared, okay? The Pythagorean identities don't have to be written exactly as they are in the chart. You can manipulate them to say other things. So this is cosine squared plus sine x, we haven't changed that, over cosine x. Then we broke it up the fraction, all right? If you notice here, they wrote the rules here so you could see what they're doing. These are fraction rules that you should already know. Cosine squared over cosine x plus sine over cosine x is the same thing. So all I've done is broken it down into one more step. This simplifies to cosine x, and this, I could technically do this step at this point, okay? This step right here is not necessary because I can do this all at once. So sine x over cosine x is tangent x. All right, so all of these have rules associated with them. This is the only Pythagorean identity. Oh, wait, right here. This is the trig rule I use. This is the trig rule. The rest of these are rules that you've learned from algebra or before. Okay, example 2. So on this side, I'm going to manipulate this side of equal sign. It really doesn't matter which one I do. Okay, in fact, you can rearrange them. It's just like algebra, but I can't move across the equal sign. So, and I could use cotangent and turn it into cosecant, but usually you look at what's the easiest one to manipulate, and that would be cosecant over secant. So Cosecant is the same thing as 1 over sine x, and secant is the same thing as 1 over cosine x. Now I'm going to rewrite this using my fraction rules. 1 over sine x times cosine x over 1. Okay, that's using the fraction rules from this. All right. Then that's cosine over sine, which is the same thing as cotangent. Now moving on to practice 2. Okay. This one says simply, it just says simplify. Okay. That means that you're using the rules to get it down as far as you can. I'm not sure. I'm not sure why the examples and practices went together like this. I apologize, but it's simplifying. So we're not actually proving anything. You're just simplifying. Here's the solution. So cosecant of x plus cotangent of x times 1 minus cosine x. I changed these using the rules, 1 over sine x, cosine over sine. And then I simplified 1 plus cosine x over sine x. And then I brought this up on top of here. Because this is multiplication, this works just fine. And the difference of squares, 1 plus cosine x and 1 minus cosine x, is 1 minus cosine squared x. By using my Pythagorean identities, I know that that's sine squared x over sine x is the same thing as sine x. Okay. All right, example 3. Now, this one I'm going to manipulate both sides. You could technically only do one side and get there, but sometimes it's easier just to work both sides out until you get the same thing. So I'm going to start on this side. Make cosine squared x times secant squared x plus 2 secant x plus 1. All right, I went ahead and got rid of that, that squared. Now I'm going to change them to cosines. I'm doing this before I distribute because it's easier, in my opinion. You could do the other way. So 1 over cosine squared plus 2 over cosine x plus 1. And now I'm going to distribute that cosine squared x. And I get 1, because cosine squared over cosine squared is 1. Okay, cosine squared x over cosine x is cosine x plus 1. Now I'm looking at this, I'm like, let's try this. Oh. This right here, I messed up when I was writing. My apologies here. So this should be cosine squared times 1 is cosine squared x, which is the same thing as that. I had notes that I was writing from, and I guess I wasn't paying attention when I wrote that down. I apologize. That should be cosine squared x. All right, practice 3. Okay, again, you manipulate both sides to get where you want to go. And solution? Maybe? Okay, here's your solution. So I'm going to start with one side. Cosecant x minus cotangent x is 1 over sine x minus cosine over sine. And then I simplify and I get 1 minus cosine over sine. Then this side, this goes back to some other rules. Okay, so they proved this already. So that's why they're not simplifying this. They proved that those are already the same. So we'll talk about this one in class tomorrow. You can get there. It's just they've already shown it, and I don't have it on here. So I'll see you tomorrow.